Equation of a circle. Equation of a circle given the endpoint of a diameter. We have so many ways to show this formula or to solve this. So I think it's the simplest way. So that's our diameter. Then you will join it to form a triangle. So the first point is A, and our second point is SY. That's our point. And B. Good. So the gradient of line AP is M1. So we find the gradient of line AP is M1 and BP is M2. And we know that line AB is perpendicular to BP. Yes, that's our right triangle. So line AB is perpendicular to BP. And we have learned this one under gradient of a line. So therefore, M1 times M2 equals -1, which we learn it under gradient of a line that perpendicular. So this is our gradient. Good. So we use this gradient to solve the question. Find the equation of a circle that has a diameter with the endpoint given by the points A and B. So we use this formula, solution, to solve this. And we know that to find an equation of a circle that has a diameter, we are using the gradient M1 times M2 equals -1 because we are using perpendicular. Like we said line AB is perpendicular to BP. So therefore, our point, that's P, that's SY. So this is our equation. And we know our S1, Y1, Y2, that's our A and B. So let's substitute. Good. Then let's simplify. So we multiply through by the denominator. That's what we get. Then let's solve it. Let's group like terms. Then this is our equation of a circle. That's our equation of a circle. Good. So this is how we solve for equation of a circle given the endpoint of a diameter. If you use this formula, this is the simplest formula. Equation of a circle. So we are going to do with equation of a normal and a tangent of a circle. This is our circle. And that's our normal. That's our center. So the gradient of a normal is M1. Then our tangent, the line that touch the circle. So this is our tangent. Okay. And that's our point P. Then we'll get 90 degrees from there. So the gradient of a tangent is -1 out of M1, which we have explained in gradient of a line. The same now that we apply here. So find the equation of a normal and a tangent to a circle. So this is the circle x squared plus y squared minus 2x plus 4y equals 15 at the point -1, 2. Solution. Let's solve this. This is our equation of a circle. So let's find the center so that you can find the gradient. So you can have 2 points. So to find the center, we said that we compare with the general equation of a circle. So let's compare. This is our general equation of a circle. Then to find our center. So negative 2a equals negative 2. Then our a is 1. Then we compare to find b2. So when we compare negative b equals 4, then our b is negative 2. So therefore our center is 1, negative 2. Therefore we can find our gradient. Now we have 2 points. We have a center and a point. So we just name one. Our point is negative 1 and 2. Then our center is 1 and negative 2. Let's substitute. Therefore, our gradient is negative 2. And note that our normal is still the gradient. And then our tangent will be the negative reciprocal of the gradient. The equation of a normal is this. Then let's substitute with our point. Good. So our y minus y1, the y1 is what? Our point, not the center. So this is our equation of a normal. With the equation of a normal, we have 2s plus y equals 0 when we simplify. With the tangent, the same thing, but here the gradient is negative reciprocal. Okay, so we just substitute our point and our gradient. Then our equation for the tangent is s minus 2y plus 5 equals 0. Subscribe to Sneapelus, my YouTube channel, for more videos. Thank you. Equation of a circle. The length of a tangent. So let's draw our line. And this is my tangent. The line that touches the line is the tangent. Good. So we use the Pythagorean theorem to prove for this. We know that the longest side, that the hypotenuse, CB square equals CP square plus PB square. We are looking for the tangent, so let's make the PB square the subject. This is what we get. And then let's take the square root of both sides. So our tangent, that's the PB square, the PB equals root of CB square. That's the length of the distance between the point and the center. And the CP square is our radius. So the length of a tangent is square root of the distance between the center and the point, all square, minus the radius, all square. That's the formula. So let's solve some example. This is our example. We should find the length of a tangent from the point to the center. We are given the equation of a circle here. And this is our equation of the circle here. Now, for us to get the length of a tangent, we have to know the center and the radius. For us to know the center, like I said, we always compare our equation that is given to the general equation to get the center. And this is our general equation when we prove it. So let's compare to get our center AB. Negative 2a equals negative 4. Therefore, our A is 2. And our B, negative 2b equals 6. Then our B is 3. Therefore, our center is 2, 3. Now we know our center. Let's find the radius. Now, radius, this is the formula. We have proved it and we have showed the reason why we got this, right? Do you remember? Yes. So we just substitute and know that our constant term, that's our C, The c is our constant term, it's 3 here. So our radius is root 10. The distance between the center and the point, we know how to find the distance between 2 points, right? That's square root of s2 minus s1 all square plus y2 minus y1 all square. Yeah. So now we know our s2, our s1, let's substitute. So our distance is root 74. Now we know the radius and our distance. So the length of a tangent is root of 74 minus 10, because this root will cancel the square. So 74 minus 10 equals square root of 64. The square root of 64 is 8. So therefore, our length of the tangent is 8. That's good. Thanks for watching. Subscribe to my YouTube channel for more videos. Our last presentation on equation of a circle is intersection of a line and a circle at 2 points. That's the second, right? The point of intersection of a circle and a line are obtained by solving the equation of a line and a circle simultaneously. If only one point is obtained, then it means that the line touches the circle and is therefore a tangent to the circle. Moreover, if you obtain 2 points, then it means that the line cut through the circle at 2 points. Therefore, it's a secant to a circle. So, find the point of intersection of the line 2y plus s equals 0. The circle s squared plus y squared minus 2s minus 6y minus 15. How will we solve this? Solution. We said you may solve this simultaneously, but here, let's make s the subject. So from here, let's make s the subject. Our s is now 2y. Then we substitute s, that's 2y, in place of s into the equation of the circle. So if we substitute, this is what we will get. So in place of s, we just substitute 2y there, then we simplify. So let's solve for our y. And this one, we have got a quadratic equation here, and we know how to solve for the quadratic equation. We find the factors and then we move on. So let's factorize this. So we know our factors, right? Our factors will be negative 3 and 1. So let's factorize this. Good. Therefore, our y is negative 1 or 3. Now we know y. We can find for s. And we know that our s is 2y. So when y is negative 1, then our s will be negative 2. When y is 3, then our s will be 6. Therefore, the point of intersection of a line and a circle is negative 2, negative 1, and 6, 3. That's the intersection of a line and a circle. Thank you. This is Senior Fellows. Subscribe to my Thank you. Subscribe to Senior Fellows, my YouTube channel, for more videos. Bye bye.